Do we have anyone that disagrees with that? We have some people. Okay, so let's listen now. Okay, why is C the most significant? Yeah. No formal chart? Well, okay, let's... Okay, if I asked why is C the most significant, and what I heard was no formal charges. That's not rule 1. You have to start at rule 1 every single time. Okay? When we look at C, it has all octets. When we take a look at A, does that have all octets? Yes. And then when we take a look at B, we're missing an octet of that carbocation. So rule 1 helps us to figure out really the least significant amongst these two. Now rule 2 says what? Least amount of formal charges. Right? So now we already know B is the least significant. Now there's a tie between A and C, so we have to go to rule 2. And rule 2 says the amount of formal charges. And so from that, we know C is the most significant, and then we can stop. We don't need to look at rule 3 or rule 4. We're done. We've already figured it out. So that is definitely correct. But the logic and the reasoning behind it has to be correct. Rule 1, Rule 2, Rule 3. Go in that order. Now, if I ask you to draw resonance structures here, okay? There's going to be, we have to figure out how many electrons we have on that oxygen atom. So when we take a look at the oxygen atom, what is its hybridization state? Okay, someone raise your hand and tell me what it is. Right here. sp2. Why is it sp2? Because we have a lone pair that is what? Delocalized. So if we know that's delocalized, then we could say, hey, let's bring that down and pop that guy open. And so that resonance structure would look, the way I've drawn that would look something like this. Double bond there, like that. See, that all looks legit. Now, what's another resonance structure that I could use? I could use this one in the middle, okay? I could bring these pi electrons here, if I'd like, and then take those and put them back onto the oxygen. And then we put those lone pairs back. These two are already there. Double bond there. Single bond oxygen there. Is that complete? No. What am I missing? Well, the first thing that should glare at you is what's the overall charge of this guy? 0. What's the overall charge of this guy? 0. What's the overall charge of this guy? -1. Okay? The way I've drawn it, it's a -1. So I've made a mistake somewhere. So you have to evaluate. And really, class, you just have to go to the bonds, the electrons that you moved. I moved these right here. So there's one hydrogen, one hydrogen. There's still one hydrogen, still one hydrogen. But now we see a carbon right there with only 3 groups or 3 bonds. So that has to be the positive charge. So whenever you draw a resonance structure, you have to reevaluate what has moved. Only electrons can move, and then recalculate the formal charge on all those atoms that move some electrons. Okay, you guys have a good rest of your week.